Please be seated. Assalamualaikum and greetings to Yang Berbahagia Profesor Datin Paduka Datuk Dr. Ainuddin, Vice Chancellor Universiti Putra Malaysia, Yang Berbahagia Profesor Dr. Zakaria Hussein, Dean Faculty of Forestry, Yang Berbahagia Professor Dr. Ahmad Ainuddin Nuruddin, who will be presenting his inaugural lecture, Principal Officers, Tan Sri, Datuk-Datuk, Datin-Datin and honoured guests. Welcome to the inaugural lecture by Yang Berbahagia Professor Dr. Ahmad Ainuddin Nuruddin. To seek blessings for today's event, I would like to call upon Mr. Muhammad Syarul Ahmad Sanusi for the Doa recitation. Please welcome.
Assalamualaikum warahmatullahi wabarakatuh. Al-Fatihah. A'udzubillahi minasyaitonirrajim. Bismillahirrahmanirrahim. Alhamdulillahi rabbil alamin. Hamdan hamidin, hamdan syakirin, hamdan yuafi ni'amahu wa yukafi mazidah. Ya Rabbana lakal hamdu kama yanbaghi jalla wajhika wa 'azimi sultanik. Ya Allah, ya Rahman, ya Rahim. Sesungguhnya kami menadah tangan menzahirkan rasa kesyukuran atas iradat dan kudratmu yang telah menentukan dan mengizinkan kami untuk berhimpun pada pagi yang berbahagia ini di dalam majlis syarahan Inaugural yang bertajuk Good Fire, Bad Fire, The Rule of Fire in Tropical Forest Ecosystem. Ya Allah, ya Rahman, ya Rahim, berkatilah dan permudahkanlah perjalanan majlis ilmu ini. Jadikanlah ia seumpama sebuah taman di antara taman-taman syurga. Berilah peluang kepada kami untuk bertukar idea, ilmu, pandangan dalam mewujudkan budaya pendidikan dan menyumbang ke arah pembentukan universiti pendidikan. Dan jadikanlah majlis syarahan inaugural ini sebagai pencetus inovasi, isu-isu dan cabaran ke arah kemampanan pendidikan. Ya Allah, ya Muhaimin, ya Aziz, Kau terangilah hati kami dengan cahaya petunjuk-Mu, sebagaimana Engkau menerangi bumi ini dengan cahaya matahari-Mu. Bukakanlah kepada kami hikmah dan hikmah-Mu dan limpahkanlah ke atas kami daripada khazanah-khazanah rahmat-Mu. Ya Allah, jadikanlah kami, ya Allah, dalam kalangan hamba-hamba-Mu yang beriman dan bertakwa. Jauhkanlah kami, ya Allah, daripada melenggari perintah-Mu. Kurniakanlah kepada kami kesihatan yang berpanjangan, kesejahteraan yang sempurna, fikiran yang waras, minda yang cergas, rezeki yang halal, zuriat dan generasi beriman, serta kurniakanlah kepada kami segala kebaikan di dunia dan juga di akhirat. Rabbana zalamna anfusana wa illam taghfir lana wa tarhamna lanakunanna minal khasirin. Rabbana atina fid dunya hasanah wa fil akhirati hasanatan wa qina azaban nar. Wa sallallahu ala sayyidina Muhammad wa ala alihi wa sahbihi wa barik wa sallim. Subhana rabbika rabbil izzati amma yasifun wa salamun ala mursalin walhamdulillahi rabbil alamin.
Thank you, Mr. Muhammad Syarul Ahmad Sanusi, for the Doa recitation. Ladies and gentlemen, I would like to call upon Yang Berbahagia Professor Datin Paduka Datuk Dr. Ainuddin to chair this inaugural lecture event, and afterwards to invite Professor Dr. Ahmad Ainuddin Nuruddin to present his inaugural lecture. Please welcome.
Terima kasih saudari pengacara majlis. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. Selamat pagi dan salam sejahtera. Yang berbahagia Profesor Dr. Muhammad Zakaria Hussein, Dekan Fakulti Perhutanan. Yang berbahagia Datuk Muhammad Reza, Timbalan Ketua Pengarah Jabatan Perhutanan Semenanjung. Juga alumni Universiti Putra Malaysia, alumni Fakulti Perhutanan. Terima kasih kerana dapat bersama dengan kita pada hari ini. Saya juga nampak Dr. Zain, kawan lama ya. Terima kasih kerana dapat bersama. Juga mantan dekan, bagi pelajar-pelajar yang tak tahu, Dr. Zain adalah mantan dekan Fakulti Perhutanan. Nombor 2, dekan yang kedua bagi Fakulti Perhutanan. Ya, ramai pelajar-pelajar tak tahu, tak kenal ya. Dan kita adalah beberapa mantan dekan yang lain bersama dengan kita. Juga dialu-alukan kehadiran ibu kepada Prof Ainuddin yang datang jauh daripada Setiawan. Selamat datang ke UPM sekali lagi. Saya juga nampak anak-anak Prof Ainuddin, juga cucu, ada tiga cucu di sini ya. Yang saya dimaklumkan Prof Ainuddin ada 5 cucu, tapi yang dapat hadir pada hari ini adalah 3. Juga selamat datang dan selamat bersama-sama dengan kita pada hari ini. Terima kasih kerana dapat bersama dan memberi sokongan kepada Prof Ainuddin. Dan of course yang berbahagia Profesor Dr. Ahmad Nuruddin, VIP kita pada hari ini, seorang yang kita raikan dan kita tunggu apa yang akan diberitahu nanti. Kita alu-alukan juga lah. Saya mengucapkan tahniah kerana telah berjaya sampai ke sini untuk memberi inaugural lecture. Satu-satunya bila seseorang pensyarah menjadi dilantik sebagai profesor, satu perkara yang sangat patut dibanggakan oleh semua profesor adalah untuk berkongsi apa kejayaan dan pengalaman mereka sehingga mereka dilantik dijadi seorang profesor. Dan ini adalah kemuncak bagi seseorang profesor. Bila dilantik, ianya mesti mengadakan inaugural lecture untuk dikongsi bersama dengan semua masyarakat. Semua pegawai-pegawai UPM, tetamu-tamu jemputan, rakan industri dan juga pelajar dan hadirin hadirat sekalian. Alhamdulillah, syukur kehadrat Allah Subhanahu Wa Taala kerana dengan limpah kurnianya kita masih lagi diberi peluang untuk bersama-sama bagi meneruskan usaha mempertabatkan kesejanaan ilmu pada pagi Jumaat yang barakah ini. Saya mohon untuk teruskan dalam bahasa Inggeris. Profesor Dr. Ahmad Ainuddin was born on February, boleh sebut dah tahun berapa? On February 9, 1960. Jadi kita tahulah umur dia berapa sekarang ya. In school quarters in Lekir, Perak. He is the third generation educator since both of his parents and grandfather were teachers. He received his primary education in Anglo-Chinese School, Kampung Ko, Setiawan, dan secondary education in Anderson School, Ipoh, Sekolah Menengah Sains Kedah and Sekolah Menengah Sains Perlis. After MCE, he was awarded Mara Scholarship to further study his studies at Ohio University, Athens, Ohio, USA, in fall 1978. There he obtained his Bachelor of Science in Microbiology in 1982 and Master of Science Environment in 1985. He joined the Department of Forest Management, Faculty of Forestry, University Putra Malaysia in June 1985, and in 1991 he continued his study at Stephen Austin State University, Texas, USA, under the supervision of Regent Professor Dr. Chang Ming Teh, and he was awarded Doctor of Forestry, Microclimatology in 1996. At SFASU, he was awarded Teaching Assistant position, and he was promoted to Associate Professor in June 2002, and in April 2015, promoted to Full Professor. Dah 4 tahun lambat dia, Prof. Okay. Kita harap semua dapat bagi inaugural lecture secepat mungkin ya. Bukan lama sebab bila dah dilantik lama tu dia dah, yang lama tu dah basilah perkara-perkara baru pula ya. Dan saya baru diberitahu pun ada seorang profesor yang retire tanpa memberi inaugural lecture. Itu adalah satu kerugian. Kerugian bukan saja untuk universiti untuk dapat maklumat tentang kejayaan beliau, tetapi kerugian kepada beliau sendiri sebab beliau tidak dapat share dia punya pengalaman dia, kejayaan dia dengan rakan-rakan sejawat, dengan orang ramai, dan pengalaman ini dibukukan, ya, buku Inaugural Lecture ni kita bukukan. Jadi kalau tidak menjalani memberi Inaugural Lecture adalah satu kerugian bagi seseorang profesor. And Professor Ainuddin has held several administrative positions at UPM for 20 years. He was appointed head of Department of Forest Management, Faculty of Forestry from September 1998 to August 2001, Head of Laboratory, Rainforest Academy, August 2003 to August 2005, Deputy Director, Rainforest Academy. And when Rainforest Academy merged with Institute of Tropical Fiber, Introp, itu Institute of Tropical Fiber, Introp, ya. Dulu ya, ya, dulu ya. Yeah, he was appointed as head of Techno-Economics Laboratory, Institute of Tropical Forestry and Forest Products, Introp. Okay, sebelum tu it was a different. From November 2006 to 2009, and later on become the Deputy Director, and now appointed as Director of Introp. Professor Dr. Ahmad Ainuddin has authored and co-authored more than 100 peer-reviewed articles and book chapters. He has also presented 124 papers in national and international meetings and conferences both locally and internationally. He has been invited to be a reviewer for different journals such as International Journal of Wildland Fire, Journal of Tropical Forest Sciences, Science Malaysia Journal, Malaysiana Journal, Botanica Journal of Tropical Agriculture, Malaysian Forester, and ASEAN Journal of Plant Sciences. And he is a member of editorial board for Journal of Tropical Forest Research at Kasat University. In research, he has been involved in two main areas, microclimatology and forest fire management, and has obtained a total of Ringgit Malaysia 1.9 million in research grant from various research and also in Korea. This is reflected in his co-authorship of publications with colleagues from different countries and institutions. The networking is very important for all of us to do. In terms of when you do research, you should collaborate with other international collaborators so that your research can be disseminated, the findings can be disseminated worldwide, not just in Malaysia. And Prof. Ainuddin has extensive international linkages. In July 2018, he was invited to Global Forest Fire and Climate Change Experts Meeting to develop an issue paper for the World Bank. He is also one of the founding members of the Southeast Asia Forest Fire Scientists Network. So he is one of the I think maybe the only one in Malaysia. During the interview when I asked him, he said he's the only one in Malaysia in the forest fire scientist. I'm not sure whether there is more now, but he is a renowned person, a very important person in forest fire. In consultancy work, he has been invited by international agencies such as Danida, APAFRI, several government agencies such as Forestry Department of Peninsula Malaysia, Economic Planning of Unit of Prime Minister Department, and MITE for consultation on forestry and environment-related projects. Prof. Ainuddin is also active in professional services. He is the Deputy Coordinator of the Forest Fire Research Group, International Union of Forestry Organization, based in Vienna, from 2006 until now, and was a member of the advisory group for the Forest Fire United Nations Office for Disaster Risk Reduction. He was also the president of the Malaysian Society of Arborists for 2 terms, from 2013 till 2018. Currently, he is in Component Executive Council for International Society for Arboriculture, Council member for Malaysian Society for Engineers and Technologies, or MISET, and he was also co-convener for 2 IUFRO World Congress Technical Sessions on Forest Fires. Professor Ainuddin was bestowed with numerous awards. One of the awards is in the Canadian Forest Research Merit Award given by the Minister of Environment Canada for his involvement in adaptation of Canadian Forest Fire Index to Malaysian Forest Fire Danger Index. I do not want to describe more. There are many things that he has achieved, and his other achievements are as written in the inaugural book. And later on, when you meet him, you can also ask him further what has he achieved, okay? Because we want to give him more time to present to us what he has done. As a professor, Prof. Ahmad Ainuddin has achieved excellence in teaching, research, professional services, administration, and leadership. Let us now listen to Professor Ahmad Ainuddin's inaugural lecture entitled Good Fire, Bad Fire, the Role of Fire in Tropical Forest Ecosystem. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Bismillahirrahmanirrahim. Thank you, Datin, for the introduction. Yang berbahagia Profesor Datin Paduka, Datuk Dr. Ainuddin, Naib Chancellor Universiti Putra Malaysia. Yang berbahagia Profesor Dr. Muhammad Zakaria Husin, Dekan Fakulti UPM. Yang berbahagia Datuk Reza Awang, Timbalan Ketua Pengarah Perhutanan, Operasi dan Teknikal, Ketua Kanan UPM, tetamu jemputan, rakyat industri dan juga keluarga mak dan keluarga saya. Dan Assalamualaikum warahmatullahi wabarakatuh. InsyaAllah pada pagi ini saya akan membentangkan tajuk Good Fire, Bad Fire, the Role of Fire in Tropical Forest Ecosystem. Ada komen kata tajuk ni panas, jadi kalau bilik ni panas, ni sebab tajuk dia panas. Dan saya akan mempersembahkan lecture ni dalam bahasa Inggeris insya-Allah dengan izin. So that the title was given so that we have some ideas of a different role of fires. So many people think fire as a bad fire, but there are also a good role of fire. That's why I choose that good fire, bad fire. And the content of the talk will evolve. First of all, the first part will be on the overall picture of forest fire, and this will entails the involvement of fire within the Earth geological time. And then I'll discuss on the impacts of forest fire on vegetation and ecosystem, and a little bit part on the forest management and also looking into the future. So in the time scale, this lecture talks about the old years ago until in the future. So it's quite but the talk is short, but the scope of the talk is very long. Okay, when I began to write and do research on the book, the first thing that come to mind, how was the fire formed within the Earth geological time? And we know that fire is a fundamental component of dynamics of the Earth's environment, meaning that within the Earth processes, fire has already been part of the processes that plays an important and vital role in the Earth formation and also the Earth process. And these scientists that are called paleo fire scientists, they look at what they call it as a fossilized charcoal, which is called inertinate, means that charcoal in the rock, in fossilized as a rock, and that is an indication of the events of fire. Okay, when there is a fire, we have charcoal, right? But these charcoal are embedded and become fossilized, and that indicate the happenings of fire, and it coincides with the appearance of the terrestrial plants in the Silurian, the third period of Paleozoic era. This is what I call the Earth geological time, and meaning that when there is appearance of terrestrial plant, so the process of fire began. So quite interesting. And these early plants colonized the land surface, and also this plant were responsible for the mid-Paleozoic oxidation event. I will explain later. Through greatly increasing organic carbon barrier, which was the net long-term source of oxygen, meaning that we know that the oxygen for this Earth is around 31%. But along the Earth geological time, the concentration of oxygen increases until 35%. Right? So we are always, thinking that the Earth oxygen is quite constant, but early part of the Earth formation, there was changes in the oxygen due to the formation of processes of certain plant. And then less Earth activity during the end of the last glacial period than today due to lower levels of carbon dioxide and cooler climates. So this is important because now we are looking at the climate change issue, where there is increase in carbon dioxide. So meaning that the Earth hemisphere also has undergone certain changes during the Earth geological age. And vegetation fires increased since the start of the current interglacial Holocene period. These are the Earth geological events. Okay, this is a good graph which explain the level of oxygen. This graph, there are two main points here. Both are oxygen level, and the line here is the PAL, present atmospheric level, which is around 21%. And you can see that the Earth oxygen level increases until in one study was 35, and another study was 30%. Okay, and also this is also the event where the earliest vascular plants came into being, and then the plants evolved to be, become different types of plant and so on and so forth. And also this is where the first evidence of fire from the fossilized charcoal formation. So this gives us some idea the processes of fires within the Earth geological history. And if you look into this graph, okay, just look at the first graph here. This is about the incidence of forest fire. You can see that during this, on the blue circle here, there is a increase in forest fire incidences, and this coincides with the increase in oxygen level, and this tapers on until the present oxygen level, which is 21%. But the incidence of forest fire varies with human activities, to show the role of human in influencing the events of forest fire. So meaning that we have a very important role in terms of forest fire. And at the end of this graph, which is in the near future instant, there's a prediction of increase in incidence of forest fire. So this gives a very good look of how fire within the Earth geological time. So one thing came to my mind was that when was the early human able to control fire? This is also a very important event in the earth in the human history. How does human or early human at the time, which they call hominin, are able to look fire at at the forest and so on, and how do they take the fire and use it as a tool? So there are various research which is at different time of the earth, but the most finding was that was around 1 million years ago when there was a Homo erectus. Okay, this is a species of Homo of human. There are around 15 species of Homo of human. Okay, and we are one of them. Homo sapiens. And this was based on the ash plant material and burned bone fragments. Okay, so what they discovered is that for the plant material to become ash, the temperature of the plant must be at 700 degrees centigrade. Okay, that is if the fire comes from the natural and somehow goes into the cave. But there was also bone fragments. The bone fragments can only be burned at 1000 degrees centigrade. So this a proof showing that somebody might have used the fire or ignite the fire and burn the bones to show that how human used the fire, and that was around 1 million years ago at the Northern Cape province at the Wonderweg cave, which are now a lot of studies going on to look at the human interaction and the human activities. So this is the picture of a Homo erectus because he can walk straight, he can walk upright. And as time goes on, the Aboriginal people, they are able to use fire to modify landscape characteristics and also to use, and in South Asia, to use fire to clear for cultivation and to maintain grassland for pasture. Meaning that until now, the human are able to use fire as a tool and to use it for their own activities and for their own convenience. This I'll just a little bit on the forest fire behavior. Basically, fire is an chemical reaction. We start from the fuels are being heated up, and then after that, the fuel will be ignited at certain temperature, and then there is a breakdown of the chemicals within the fuel, and then you have the burning, and also after that, the fire has to stop. Okay, all fire in the world has to stop except maybe in the hereafter they are always in burning. And also when I work on fire, I always think of the great fire or the big fire. So this example of the development of fire from a small spot, and it will increase until it become uncontrolled. So what are the factors that influence fire? So whether there are three important factors which influence fire. One is weather and climate. The other is forest fuels and topography. These are the factors which influence, and this is what our work starts with. In order to understand fire, we look at different climatic conditions. We look at different types of fuel, so that we are able to understand and to hopefully to predict fires. So in terms of weather climate, there are short-term atmospheric process which we call weather, the air temperature, the daily rainfall, the wind, the solar energy, and the humidity. These are influence forest fire. But there are also long-term processes which we call climate. And these are in Malaysia. It is monsoon season. We have monsoon, the northeast monsoon, the southwest monsoon, and also the retreat and the advance of the monsoon play an important role in in also in some of the weather events. Basically in April, we usually have a very violent storm. I remember last year in UPM, we have a lot of damaged trees when there is storms, and this was in the inter-monsoon because the atmosphere and the air is not stable. So UPM has to be on guard during April, because that will when the trees maybe have problems or fails. And there are also long-term dry spells and drought, and this is when usually the fire will happen. And these cyclic droughts do occur at certain events, usually 3 years to 5 years. And this is what we call El Nino. Okay? And our work, which we look at the weather and climate, how they influence fire, we use drought index. And there are many various drought index, and this one we use a KBI, Kish-Byram drought index. They also have a standardized precipitation index. And if you can see here, you can see this is a daily drought index of one locality, which is Kelantan. And you can see that they have this index can be interpreted in different ways. You have the extreme, the moderate, and the low. So we are usually looking at when will be the extreme, because that will be the events of forest fire. And this is the daily trend of forest fire. And usually that in terms of forest fire, you have two important dates. During February and March, usually you have events of forest fire. And also during June, July, August, usually there is also events of forest fire in the tropic in Malaysia. So that's where the people should be aware, and also if those who manage forest fire, that will be the event where they should be ready. And the other events which have occurred, big fires event in Malaysia and also in this region, the El Nino. And the El Nino, they comes in various strength. And in 82 and 83, there was a very, very strong El Nino, and there was a massive forest fire, especially in Borneo. That's why we have a big forest fire. And then you have another big one in 97 and 1998, and this one we can feel it in Malaysia. We have forest fire, and also after that we have haze. People realize that when people don't realize that when you have fire, then you have haze. But people only see the haze. And the last one was in 2015 and 2016. We have very also big haze event. So this is, and usually this haze were from Indonesia. But I have a colleague or friends we work together, and we always joke why Indonesia is always trying to bring us the haze. They say that why you complain? The haze is only once in a month, or you never complain when you give the free oxygen, every day coming from Indonesia. You only complain during haze. Okay. So I say thank you for your oxygen. And what are the factors also influencing forest fire? The fuels is very important. That is also where we do our work. And this is in Ethiopia. One of my PhD students, one from Ethiopia, and I managed to visit Ethiopia for 2 weeks to look at his work. So basically, people there, they are very dependent on bioenergy. They scavenge wood from the forest, and also not only the wood. You see here, they also sell the wood, and also they also pick the leaves. And in Ethiopia, they have this Eucalyptus globalus, and they use this leaf to cook certain types of dish called injera. And now when they want to make injera, they have to have eucalyptus. If not, they cannot get the flavor. That eucalyptus was introduced. So wood play an important role in terms of providing energy. There are also other characteristics of forest fuel that we investigate, the chemical characteristics. how the fuels are distributed, and what are the thermal characteristics. Because in order we want to calculate the energy part of the fire, we need to understand the thermal characteristics of the fuel. So this example of 1 hour study, we look at different species in peat swamp forest, and we can see that in terms of the extractives, because part of the in chemical content of the leaves, the extractives are important because they provide for the enhancement of fire. So we can see that in blue, where they have the alcohol accidentability, there are variation within the species. For example, here you have a high Uncaria, you have also high compared to the lalang, the impreta, and also the melaleuca and so on. And also in opposite ways of in terms of fire, ash trend to reduce the ignition of fire. So there are different chemicals content within the fuel that influence fire behavior. And we also look at the energy of the fuel. Here we look at the leaves of different Shora species, and you can see there are variation within the leaves. And from the fuel, we also look into the different components of the fuel, where we have the liter, the downward materials, and this give different dynamics of the energetics of the fire. And then topography is also the influencing part of the forest fire. But now let's look at the fire and vegetation. Basically, we can divide the relationship between fire and vegetation into 3 distinct categories. One is fire dependent, where 50% of the terrestrial area are dependent on fire. Okay, this I will explain later. Then we have the fire sensitive, and also we have the fire independent. So in the fire dependent species, these are the trees or vegetation which need fire in terms of their biological cycle. In fire sensitive areas, this fire plays an indirect role in maintaining the natural ecosystem, and meaning that the area is not usually fire, but once they have fire, then they are affected by the fire. And the fire independent are the ecosystem that have lack of fire or fuel, and these are usually very small. And you can see that the earth has been mapped according to the 3 categories, and this was our work using sponsored by the Nature Conservancy, where scientists from different parts of the world give their opinion on what are the status of their vegetation. And you can see here in Malaysia, there are mainly fire sensitive plants. So this just to show the relationship between the net productivity, the net primary productivity. Basically, when plants take in carbon dioxide and produce oxygen, they grow their biomass, and this is what we call the productivity. And we can see that they relate well with the numbers of fires occur. Looking at in Malaysia, you have this fire between 5 to 19 or per year. And this is a simulation of happenings of fire, a yearly 1 year simulation from January to December. You can see that in our country, Indonesia, there are events of fire occurring along the year. And as you can see now, we also have problems at our neighbor, the Thailand, where they have problems with fire. So now let us talk about the forest fire in Malaysia. Okay, so forest fire in Malaysia is still relatively new in terms of research, And there are records of fire when when the ship during the colonial times, when the British came to Malaysia and they used ship to communicate or to transport. There were reports of a lot of haze in Sarawak in the 18th century, meaning that events of fire has been going on, but maybe the time it occur is far apart. So that is why we do not really feel the events of fire. But as times goes on, now the events of fire are become regular. And so there is a concern of identifying fire, and in some places, for example, in Sabah in 1823, they have a very bad event of forest fire. A lot of fire destroy their forests. So that's very important to have early detection and also mapping of forest fire hazard, so that we are able to take certain steps to reduce forest fire. And one of the places where you have forest fire in Malaysia is tropical peat swamp forest. And this is where you have a lot of forest fire occurring in that places. And so most of our work in forest fire are working with tropical peat swamp forest. So what is a tropical peat swamp forest? Basically, it's just an area you have a lot of water due to the topography, and then over the years you have accumulation of trees and woody materials, and this accumulate over time. And after that, you have a layers of organic matter which is been inundated by water for a long time. So the process of degradation is very low. And after a long time, maybe 4,000, 5,000 years ago, you have an accumulation of woody materials. So that is okay because it's always underwater. But when humans come, they start to harvest the area without really doing a good job of preserving this area. So they start to build canals into this one to take out the wood outside. Okay, this is what happened. When you start to build canals, you can see that it is above the water level. And then when you build canals, the water will start to come out. Then you have to have a process of the drying of the peat swamp. And that's what happens when there is a fire. And Indonesia and also in the early part of Malaysia, there are activities going on. This damage the peat ecosystem and dry up the peat ecosystem. And when you have a fire, then it will start to burn because it is all dry wood. You can imagine that you have dry wood and this which burn, then it will burn for on and on. So this is what happened when we have this the haze in 2015 and 2016, mainly from forest from the tropical forest. So the peat is very important because it serves certain biological functions, and we know that because of that we have we used to have a dry season and wet season. Now we have the 3 season: wet season, dry season, and haze season. So that's also good for tourism because we have increase in season. And this also influence because haze is a particulate, and other than that, it also produce carbon dioxide. It also produce methane, nitric oxide. These are greenhouse gases. So the implication in terms of the atmospheric gases that it influence the emission of greenhouse gases. So this is very important in trying to understand how fire burns in peat forest. So that is what we are doing now. And in terms of the impacts, we have impacts of fire on ecosystem, and fire has no standard response. It depends on the type of the vegetation. It depends on type of soil. It depends whether the fire is low fire or high fire, or it depends when is it just a short-term fire or long-term fire. So there's a lot of variation between the response of forest fire into the ecosystem. And also in terms of the ecosystem, we see fire as a disturbance to the normal ecological processes. Basically, we have succession, and then because of disturbance, this will affect the successional process. And if you have a short, low, moderate fire, it may have less damage. But if you have a high severity, it will replace the whole forest stand. And it may not be that negative because some species will depend on this type of fire. So that's what we call the good fire and the bad fire. So we can see that the impacts of fire on the soil ecosystem, they have different effects on the physical effects, the effect, the bark density, the changes. It has effect on the chemical effect because it contributes to the certain nutrients from the trees into the soil. And then you have biological changes due to the heat. This will affect the flora of the soil. So we do some work also on soil. We look at the chemical content. You can see that there's increase in potassium content. And also the increase in sodium content. This is work by Shaufina. Now she's a lecturer at the Institute IPB University. She's still doing on forest fire. And so we have phosphorus. These are soil nutrients that can improve the soil. So you have an increase here. We compare between the burn and the non-burn, unburn. You can see that increase in phosphorus to the soil or to the pit. So you can see the damage also depends on the intensity of fire. And it's not only the forests are affected, the agriculture, because there are a lot of agriculture activities in the peatland areas. You have the oil palm, okay. So you can see the damage. The trees just fall down because we have fire and it will burn the roots. You see the crown is still green, but it falls down because of the underground fire in the pit system. And you can see that, I always like to show the picture because there is human element to this disturbance. So this very sad because he has to deal with his oil palm and so on. And most of our work is been done in Raja Musa Forest Reserve in Selangor. We thank you the Jabatan Perhutanan Negeri Selangor for their cooperation in doing our work. So they have places where they have a recurrent burn event. And we look at the structure of the forest. Basically, the forest will affect the stand structure, and it also will have some events on the different species and so on, because some species can withstand fire and so on. And this also affect their diversity of the forest areas. And also we do work at Pai Indah Pit Song Forest near to Dekan House. So by that time his house was not there. If not, we can go and ask for drinks after we work, Because it's very hard to work in Pit Song Forest because it's hot, it's wet, and sometimes your feet will fall down into the pit. But that is science, So you have to enjoy doing it. So that is also affected by, we also look at different stand structure, the seedlings, how it differs, and also how the different species will be affected. Different age group will also be affected because usually the big trees will be able to withstand more from the heat of the fire. So this will affect the species diversity of the areas. Okay, so we have seen the impacts. So how do you manage the fire? Okay, that is very important. So we need to understand. That's why we need to have people who work on fire, because by understanding these processes, then we can offer solutions. And so part of our work was also looking at the forest fire management aspect of trying to reduce the risk of forest fire. So one of the things that we do is we look at hotspot. Okay, and this is been done through satellite hotspots. And this is yesterday's hotspot in Malaysia. We got it from NASA. So you can see that at this, what state is this? Huh? This is Terengganu, right? So they have, and usually at the coastal area, they have places where they always have forest fire because of the nature of the area. And you see in Sabah and in Sarawak, Musri, my PhD student, is now working in Bin Suluk, Klias. So I think this the area is still burning. So hopefully they will not affected your trees. So hotspot will help to detect the fire. What a hotspot is just a pixel where the temperature is at certain level. This is what we call the threshold. And this is being monitored by different type of satellites. So we did a study on to look at the trend of hotspot. This is the trend of hotspot for Sabah. So we can see that for March, August, September, there are more hotspot. This indication of fire, and maybe it's forest fire, maybe it's just plantation fire, but to give us some indication of the events of forest fire. And from that, we try to develop what we call it a prediction, so that we know that which area has high risk of forest fire, and we use different types of indicator. We have the road, because road, the more road you have, the more people have access to the forest. We have the town, the river may be positive or negative. Then we have the forest cover, the forest food, and so on. And using the geography information system, we develop certain indexes, and from that we develop a forest fire hazard map. So this is the different hotspots at different part of the year, and then from that we will get certain index. And also we do work in Sumatra, and this is also work by Indonesian students studying here in UPM, but she's doing from the looking at the computer science. She works in the computer science faculty. Basically is to predict the occurrence of hotspots. So basically we also look at different land covers. You look at the road, you look at the different villages, and so on and so forth. And also different types of pit, because pit you have different levels, different depth, and so on and so forth. And from that we try to predict the occurrence of hotspots. So this is using what we call a data mining technique. They have different types of data mining technique using different type of classifier. Okay. And from that, we also need to do some kind of rehabilitation of the degraded burn area. This is also some of our work, and currently we are looking at the certain type of plant so that we are able to ameliorate or to rehabilitate this burn forest. So before we want to rehabilitate the burn forest, we need to look at the underlying issue, basically the drying up of the pit. So there's a lot of effort to block the canal. This has been done by Jabatan Perhutanan Negeri Selangor at Raja Musa, where they block this canal so that the water will not flow out. There will be some amount of water, but when they block this one, the water level will rise up. So this wet the pit. So this will help to reduce the fire. And also we need to understand to choose what kind of species is suitable. The criteria will be the fast growing species, and also the fire adapted species. Now we can look at which species can withstand fire better compared to other species. So the example of the effect of fire, you can see that when it burns, really burns. You can see here at back here, or brown up. So you need to control the water level, and also from that you can start planting and try to rehabilitate the area. So these are some of the species, Melaleuca, which are also adaptive species because of the thick cover, and when it's burned, it's just burned outside. So you can have more of this species by survey and so on. So we can recommend the planting of this type of species. You can also do natural rehabilitation, but it will take longer, and the fire may come again and so on. And you can see that these macaranga start to come up, and different type of species to colonize the burned area. So we also do some rehabilitation, guided rehabilitation. This is near the coastal forest. So by having this type of screen, this will protect the seedlings, and we have a better percentage of survival and also success. So these are different species and so on. And now there's a trend of using a community-based rehabilitation. This is, like crowdsourcing or asking people to come and plant, different. And this has been done in Raja Musa through the Global Environmental Center. It's an NGO where they have in 1 month, they have one day, usually on Saturday, where you can go and plant, help yourself to plant and to improve the pit areas and so on. And also it's quite successful because people like to do that. And we should rather try to get people to join the effort of rehabilitate the areas and so on. And in one sense, it also helps us to provide awareness the importance of pit, and also the fact that you go and plant shows that you are concerned. So people are more trying to do a more positive work. And that is also one of our PhD work, looking at how people respond, how people can put their time in terms of improving or doing some rehabilitation work. So now we enter to look in the future. What will be the event? What will be the because our Earth is changing. We are in the Anthropocene period, where human has played an important role. So in terms of the future, there are a lot of projection going on, and most of the climatic projection says that future global climate will have an increase in global temperature in aridity. Means that it's getting hotter, and also it will be more drier. Okay, so when it's hotter and drier, it means that it's easy to burn. So someone has to replace me when I get retired, because there will be a lot of forest fire. So there's increase in water precipitation and drier vegetation, and increase in air causes atmosphere to have a capacity to hold more water and causes lower soil water table. The soil will be drier, so you have fire. And this will have a higher risk of forest ignition. So that will be the future outlook that been predicted by the scientists. So it's so if you look into the vegetation, then we should ask, as a scientist, how would that they respond to this kind of environment before fire and so on. So this is a good also research question. So you have an increase in fire occurrences. Longer fire season means that there will be more time for fire, and the fire will have more higher intensity. Means that the fire will be more hotter. An increase in fuel consumption and more area burn. This is what when we discussed in Vienna last time, where we have a different scientists where they discuss based on their findings. So so fire is getting important, and we should also put effort in terms of trying to understand the fire and efforts on how to detect fire and to you cannot put out the fire, but you can control the fire. So we are also doing a project now based on IoT. This is based on our collaboration with Prof. Burhan. Thank you very much, from engineering. So he's a wireless man and also good in IoT base. So we managed to secure funding from Japan and ICT, and from that we managed to initially we have different countries including Vietnam, but the Vietnam opt out. So we have the Malaysia, we have the Indonesia and the Brunei. So now what we are doing is to have an IoT based solution. We also try to ask funding from MCMC, Multimedia Commission, what we cannot get. There is one representative here, my brother, but he still did not give me the funding. So maybe different people can apply for the funding. No chronism. So what we're doing is that we are connecting these areas and look at different events of climatic condition or the kind of fire, and try to predict the event before it happens, so that we can give solutions. So we are going to put the different sensors, and this all will be wireless using different technology, the LoRa technology and so on and so forth. And this will be put into cloud. People are talking cloud. So this cloud, then we can share the Brunei people, the Indonesia people, and we can develop solutions. That will be the future. And we thank you, the JPNS, for agreeing for this project. And using the data analytics, we have now the machine learning, the AI, and this work hopefully by Dr. Sharifah from engineering. So this we can hopefully develop an early warning system. So we are excited in this project. Hopefully it will come out. So we still need Prof. Burhan, so you can ask for more extension. So as a conclusion, forest fire causes impacts to our ecosystem, resources, and some of the impacts are negative and what are beneficial. That's why we say it's a good fire and bad fire. It's not only bad fire, but it's good fire and bad fire. Understanding the role of fire in the ecosystem is important in developing a sound forest fire management program, prevention. So we need a good science, we need more researcher, and I'm happy that Dr. Zahir Shah from engineering is also interested in looking at the dynamics of the pit burning. So hopefully we have young people coming in. Dr. Shariza on looking at the from Introp at different condition through satellite and GI study, different condition for fire and so on. So hopefully this give us more information on fire. And through a projected scenario, there will be an increase in forest fire occurrence with longer fire season and burning with high intensities. Impact are localized or globally, depending. It can be transboundary, like what happened to Indonesia. And the ability of cutting-edge technologies hopefully will help us to formulate a better forest fire solution, which can control and manage in forest fire in a landscape management approach. So with that, thank you very much. It's my acknowledgement. The colleagues in Faculty of Forestry, this, if they don't have a name here, all of you are included. Thank you very much for your efforts and for the cooperation. So a good environment, a good collaboration is very important for the future of for work, and also for the staff, for the lab assistant also play an important role. Cik Bahrom, Mahmud, Ahmad Som, Abbas, Kamel, and so on, and so the staff of both Faculty of Forestry and INTOP, thank you very much for the support and for the help they rendered. Thank you very much. So, terima kasih and Assalamualaikum.
Thank you, Professor Dr. Ahmad Ainuddin Nuruddin, for the inaugural lecture. Ladies and gentlemen, now let us all watch a video to look at Professor Dr. Ahmad Ainuddin's amazing journey throughout his career. Now I would like to invite Yang Berbahagia, Professor Datin Paduka, on the stage.
Thank you very much, Professor Dr. Ahmad Ainuddin. I think when I saw the video just now, the time that he was born until now, the face is still the same. There's not much change. Do you agree with me? I think you look at his photo as a child, you know that there is Prof. Ainuddin. Sometimes people change, but for him, he has not changed. So he can be forever young. So thank you very much, Prof. Ainuddin. You have given, enlightened us with what fire can do. Fire can be good, fire can be bad, and we hope that whatever that is associated with fire in our area, that's for the good thing, not for the bad thing. I was expecting Prof. Ainuddin to show fire, disasters of fire that always occur in the US, where houses, you know, millions of people, houses are burned and people have to move away, have to move around. Big disaster. It's quite often in the US because of sometimes they get the weather become too hot, very hot that it makes the fire blow very easily, that you get the fire quite easy to catch up. When I was doing my postdoc in Davis, during summer it was really very, very hot. You know, you can get more than 40 to 50 degrees. And we cycle a lot in Davis because it's a flat land, it is a cycling area. And when we cycle, you get the wind, it's as though you're coming out from the oven. You know, that's how hot it can be. And we always say that why they say that this country is cold. In fact, it's hotter than in Malaysia. And we always felt that it's really bad cycling in that kind of condition. So we heard from Professor Ainuddin just now. I think we learned a lot from what he has told us and what he has achieved from his research. And we hope that more research will be carried out. And I'm glad that he said he has his mentees that will continue the work. that is good, because fire is a very important area. And Datuk Liza, you agree with me that it is a very important area, and we need to work very closely with the forest department in many areas, especially so in fire. So again, congratulations, Prof. Ainuddin. A big applause for Prof. Ainuddin. There's no question and answer. You can ask him during the break afterwards. Thank you.
All right, thank you, Yang Berbahagia Professor Datin Paduka. Ladies and gentlemen, I would like to invite Yang Berbahagia Professor Dr. Zakaria Hussein and Professor Dr. Ahmad Ainuddin to join Yang Berbahagia Professor Datin Paduka on the stage for a photography session. Please welcome.